Hello and welcome to CEC live lectures. I hope you all are having a great learning experience through this engaging series of lectures which is being hosted for you all. I am Dr. Pavitra Bharadwaj and I am a teacher of computer science in the University of Delhi. So friends, we have been following computer networks for the last couple of lectures and this will be the 7th lecture in the series. And in this lecture basically we will be talking about the different types of signals which are used for carrying data on computer networks. Then we will be talking about transmission media. What are the transmission media which are available to build computer networks? What are the different types of transmission media, that is the guided and the unguided, and we will be talking about the guided transmission media in detail in today's lecture. So I hope that you will find this useful, as this lecture is targeted for undergraduate students studying computer science, computer applications courses in Indian universities in the undergraduate level. So let's start the lecture for today, which we start with discussing the concept of basically analog and digital data. So see, before we understand what is the relationship, right? So we must know that when we had discussed the components of a communication system, components of a data communication system, we had said that to transmit the data from the sender to the receiver, you need a certain medium through which the data will be sent, right? Now the data can occur in different forms, right? So data can be analog data or it can be digital data, right? So the most common you can say analogy when we look at these two terms, analog and digital. So in common life it's the clocks which we refer to when we are talking about analog and digital, right? So analog clocks are the ones which have got the 3 hands, maybe 2 hands, one for hours, one for minutes and the other for seconds, and in this there between any two stages so it gives you a continuous form of information the clock is giving, that is the movement of the hands are basically continuous, which is happening in an analog clock. On the other hand, if you look at a digital clock which reports hours and minutes, that will change suddenly, right? So from, say, if you have a time, say 8:05, so then it will directly go from 8:05 to 8:06, whereas in analog there will be multiple states which will be present between 8:05 to 8:06. So basically the term, when we are using the term analog and digital, it refers to a similar kind of thing, that is analog means where the information is presented in a continuous format, whereas in case of digital, if we say it's a digital data, then that refers to information which is shown in discrete states, that is from one state you go directly to the second state, right? Alright, so in analog data, so for example, all natural signals, we say all natural waves, they are analog, right? So whether it is the human voice or it is the sea waves or it is any other wave, so these are basically analog waves. They take the continuous values, they take a continuous format, right? So whenever say a person is speaking, then an analog wave is being created, and this analog wave which is created is captured using a microphone. It is converted into an analog signal, and then it is sampled and then converted into a digital signal, right? Digital data, it will take on discrete values. For example, data which is stored in a computer's memory. We all know that computer is a digital device. So all data which is stored in a computer, which is processed by a computer, has to be in a digital format. So all data in a computer is in the form of 0 and 1. So these are the two discrete values, So data is converted to a digital signal or modulated into an analog signal for transmission across a medium. So the thing which is happening here is that the data is occurring naturally in analog format, and then from this analog format, when a computer has to process the data, it is to be converted into digital format. So the computer converts this format into digital format, and then when the computer has to retransmit the data on the network, it is again converted into analog format. So the data inside the computer is in digital format, but when it is moving across the network, when it is moving from one computer to the other, then it is actually in the analog format also, because waves, they travel in the analog format, right. So now, because you understand the concept of analog and digital data, so the related concept is that of analog and digital signals. So for analog signal, you need, for analog data, you will need an analog signal to carry it forward. For digital data, you will need a digital signal which can carry it forward. So analog signal, basically, again the same thing is there, that it will have many levels, it will have infinite number of intensities over a period of time. So the wave will move from one point to the other, and it will pass through infinite number of values along its path. Whereas a digital signal, on the other hand, will have only limited number of defined values. So each value can be a number. So generally, because we are talking about computer networks and computer signals, so we will say that the two numbers or the two values in a digital signal is either a 0 or a 1, right. So the periodic signal, if you say there is a periodic signal, especially in case of analog signal, so then periodic signal will complete a pattern within a measurable time frame, which is known as a period, and then the same pattern will be repeated by the signal over subsequent identical periods, right. So the completion of one full pattern, right. So one full pattern means from one point to the identical point on the wave is known as a cycle. And non-periodical signals, they will change without exhibiting a pattern. So in non-periodic signals, you will not see a pattern, whereas in periodic signal, you will see a pattern, and that is known as a cycle. And this cycle will repeat over a period of time, right. So both the signals can be periodic and non-periodic, but when we are talking about data communications, so we will commonly use periodic signals for analog, and we will use non-periodic digital signals. So this is the characteristic that we assume. So this diagram, it very clearly shows what an analog signal looks like and what a digital signal looks like. So you can very easily see here that the value between any 2 points on the analog signal will have n number of values over a period of time. It can have infinite number of points on the wave, and every point will have a specific value. Whereas in the case of digital signal, you can see that at any time there is only two value which is possible, either the value is a 0 or the value is a 1 or a number. So digital signals are more discrete signals, analog signals are more continuous type of signals. Alright, so now when the signal is traveling through a transmission media, okay, so the transmission media, basically they are not perfect. Now when I say transmission media, of course we are going to discuss about it in detail, what are the different transmission media, but we can understand that transmission media could be anything. It could be a wire, or it could be air, or it could be any kind of optical fiber, it can be anything, right. So none of the transmission media, they are perfect, basically they have got their imperfections, and because of these imperfections or because of these issues in the transmission media or the channel, there is something called signal impairment which happens. So signal impairment basically refers to the phenomena that causes the intensity of the signal to change. Okay, we will not say whether it increased or decreased, but we will say that the intensity of the signal changed. That is, the signal at the beginning of the medium will not be the same as the signal at the end of the medium, right. So what the sender sent is not what the receiver received. If this is a scenario, then we say that the signal has been impaired. There has been obstruction in the path of the signal has undergone some change, which is definitely undesirable, and we would not want that, because ideally the situation should be that whatever the sender has sent should be received by the receiver. So therefore, now signal impairment can be caused due to three main factors or three attributes are responsible for this problem of signal impairment. So the first problem is called attenuation, the second cause is distortion, and the third cause for signal impairment is known as noise, right. So let's see what each of these means and how each of these affects the signal when it is being transmitted. So attenuation basically means that there is a loss of energy. So when a signal which is simple or composite signal, it travels through a medium, it loses some of its energy in overcoming the resistance of the medium, right. So we know that this is a very common phenomena which all of us have experienced, that if a wire is carrying electricity, then it is carrying some signal, then it gets warm, right. Even if not hot, it gets warm after a certain while, right. Why is this happening? Because some of the electrical energy is getting converted into heat energy, right. Like for example, if we are speaking, right, so air has a natural resistance, so the intensity of the signal or intensity of the sound which is felt at somebody who is closer to the speaker will be more, whereas somebody who is sitting at a distance will experience less intensity of sound. Why? Because simply the signal gets weakened when it travels through the medium. So what is the solution to this? The solution will be simple, that amplifiers will be required to amplify the signal, so that the loss of energy which has occurred due to the resistance of the medium. Now the medium could be a wire, it could be air, it could be any medium. So therefore that loss can be recovered. So the signal is not getting impaired and attenuation problem can be addressed. Now the next problem which is faced is the problem of distortion. Distortion word itself means that something is distorted, means that something has changed its shape or something has changed its form. So here also the signal is undergoing a change of shape or its form, and it can occur in composite signal which is made up of different frequencies. So what we do is we sometimes combine different signals which are at different frequencies, and we make one signal which is known as a composite signal, which is then transmitted on the medium. Now when we are using something like this, that is we are using a composite signal, then it can each signal which is composing or which is making the composite signal will have its own propagation speed through the medium, right. And therefore because the speed is different, therefore the time at which this will arrive at the destination will also be different. So every signal out in a composite signal, if you had 3 signals actually, so of these 3 signals, every signal will have its own propagation speed, and therefore it will arrive at the destination at its own time, right. So therefore when they arrive, the difference is there is a delay which is created, and because of this delay which has occurred, there will be a difference in the phase if the delay is not exactly the same as the period duration, right. So if the delay is the same, then there will be no phase difference, but if the period and the delay are not same, period is the the characteristic of the signal that we just discussed. So in other words, what we are saying is that signal components at the receiver have phases different from what they had at the sender, right. So the shape of the composite signal therefore will be changed, and therefore we say that there is a distortion which has occurred in the signal, because the composite signal, there was a delay in their time frame, there was a mismatch in the time of the individual signals which made the composite signal. So here it is very clearly shown here also that at the receiver's end what the receiver sent, but when it was because of the different signals there was a different delay in each of the signal, therefore the final result which is received by the receiver, the shape is slightly changed. So the signal is not the same what was sent by the sender, the signal has been distorted. The third reason for signal impairment is the noise. Now noise is also a cause of impairment, because several types of noise can be there, such as thermal noise, induced noise, or there can be crosstalk, impulse noise may corrupt the signal. So because of this, what happens is, say for example thermal noise, that is there is heat in the vicinity of the transmission media, or the transmission medium gets heated up, right. So because of which what will happen, that there will be a random motion of electrons in the wire which has got heated up, and therefore this random motion of electrons will create an extra signal which was not there originally when the signal was transmitted by the sender. So because of this, different types of changes will occur in the signal, because we are saying that an extra signal has been added, or an extra value has been added to the original signal. Say for example, there can be other sources of noise. Say for example, there is some motor, or there is some appliance which is near to the antenna. So what they do is that all these devices which are generating some kind of parallel signal, they will act as a sending antenna, and the transmission medium will act as a receiving antenna. So the transmission media will start capturing the data, which is the signal which is being generated by these devices which are producing some kind of sound, right. Then another could be crosstalk, that is when one wire is on the other. So the one wire is acting as a sending antenna, and the other wire starts acting as a receiving antenna, right. Then sometimes we also see that there is a spike in the signal. What is a spike? Basically a signal with very high energy, right, that comes from say power lines or lightning, etc. So that can also affect your signal quality. So basically noise coming from any source, whether it is from appliances, or it is from the other wire, or it is coming from voltage or lightning, etc. All of these can cause impairment of the signal. So we can see here that what signal was transmitted and what has been received. So you can see that there is a sudden spike in the signal because of the vicinity. There is a lot of noise, some different kind of signal is being captured by the transmission media, and the resultant signal therefore is not the same what the original signal was. So therefore these three major reasons are, and major causes are understood for signal impairment. Now when we look at transmission media, we will try to see in each of the transmission media that which all which all transmission media are able to fight which all reasons of signal impairment, because at the end of the day the aim of the whole thing is to provide the destination with the signal same that was sent by the sender, by the transmitter, right. So now we will discuss about the transmission media which are which are used to connect the sender and the receiver. So we had discussed when we were talking about the TCP/IP protocol suite and the layers, we had said that the physical layer is actually the first layer of the TCP/IP protocol suite, and below it is the transmission medium, which could be either cable or which could be air or any of the transmission media, right. So the physical layer directly controls the transmission media which is below it, right. So transmission media, we say it actually belongs to the layer 0. So if you remember, physical layer's main function is to convert the frames into bytes, because transmission media is only going to carry bytes. So whatever information the physical layer gets from the layers above it, it converts it into a format so that it can be converted into, it can be loaded onto the transmission media and it can be transferred through this. So basic role of transmission media is to convey or is to carry the signals from the physical layer of the sender and deliver them to the physical layer of the receiver. So this the whole thing works at the level 0. So a transmission medium can be broadly defined as anything that can carry information from a source to the destination. So we've already seen that it could be air, it could be any other transmission medium. So if we talk about person to person communication, so if two people are speaking, then air is the medium. If one person is sending a letter to another person, then the mail carrier is the medium, right, or it could be the plane which is carrying the letter. So, whoever is carrying the message. So, basically transmission media can vary, right. So, in data communication, of course, the definition of information and transmission medium is more specific, right, because transmission medium is the free space, or it could be a metallic cable, or it could be optical fiber. So, usually a signal that is a result of conversion of data from another form. So, usually the information will be created, as I just said, that it is converted from the frame to the byte form by the physical layer. So, if we look at this classification of transmission media, so transmission media can actually be classified as two. One is the guided media and the other is the unguided media. So, unguided and guided, the main difference is that unguided means it is wireless and guided means that the transmission media is a wired media. So, wired media means that the signal will be confined to the limits of that wire only, whereas in wireless media the air or the free space will be used as a transmission media. So, the signals are not confined to a particular path or a particular area in which they will flow. They can take any path, they can take any particular route for moving. So, in guided media we talk about twisted pair cables, we will talk about coaxial cables, and we will talk about fiber optics cable. And in unguided media we will talk about three types of waves basically, that is the radio waves, the microwaves and the infrared waves. So, first we will look at what happens in case of guided media and then we will talk about the unguided media. So, guided media, as I already said, that in this case the signal will be directed and contained in the limits of the medium. Okay. So, the simplest of these is the twisted pair cable, and the most sophisticated and the best out of all guided media, which is most commonly used these days also, is the fiber optic cable. Coaxial cable lies somewhere in the middle of the two. So, first we look at the twisted pair cable. What happens in a twisted pair? So, the name itself suggests us that in this there will be a pair of cables which will be twisted along the length of the wire, right. So, this is a very common transmission media which has been used commonly in building LANs and telephone cables, etc. So, there is an insulator which is covering the wires, and there are two wires which are spirally intertwined against each other, right. So, one of the wires is used to carry the signal to the receiver and the other is basically used for a ground reference, right. So, the receiver will actually use the difference between the signal and the ground reference. So, in addition to the signal sent by the sender on one of the wires, there is interference and crosstalk may affect both wires and create unwanted signal, because the two signals are the two wires are metallic wires and they are very close to each other. So, there is a lot of possibility that one wire starts acting like a sending antenna and the other wire starts taking the signal. So, therefore, this problem of noise due to crosstalk is very common in case of twisted pair cables. Now, if the two wires, now there is a reason, there is a specific reason why the wires have to be twisted along the lengths. Why should they not be simply parallel to each other? What is the reason for coiling them? So, if the two wires are parallel, the effect of the unwanted signal, that is the crosstalk that we are saying, it is not the same on both wires, right, because at different locations the noise or crosstalk will vary, right. So, therefore, there will be a difference in the result what the receiver is getting. But when we are twisting the pairs, then this balance is maintained. That is, how much crosstalk is happening at one point, similar crosstalk will happen at the other point also. So, therefore, the unwanted signals are mostly cancelled out, and therefore, what the user or what the receiver gets will be somewhat noise free or relatively better quality signal. So, therefore, twisting of these wires is a feature which has been incorporated to reduce the effect of crosstalk because of the wires being parallel to each other. So, we will be continuing with our discussion on twisted pair. Thank you.